Hello, welcome once again to Jamb 400 series, a beautiful program for all UTME students. In this program, we'll be dissecting different Jamb questions from the past questions. Today, we are looking at mathematics, and we want to consider the question in 1994 question number 3. All right, we don't have time to waste, so we are not going to waste any of our time. So let's begin immediately. But do well to subscribe to our YouTube channel and also follow us on Facebook, and make sure that you share this video and also leave a comment for us. It's very, very important. Share this video now so that others can benefit from these videos. All right, thank you. Let's begin without taking much of your time. If we look at the question that we have on the board, we'll discover that the question is from logarithm. Theory of logarithm. We know we have different aspects of logarithm: logarithm with tables and logarithm without tables. So this one is logarithm without tables. So how do we go about it? Which aspect of logarithm without tables do we have here? Division of logarithm. So we have this divided by this, and we have rules. If we want to solve this problem, we have rules or steps that we need to take. So let's look at the question. Log 0.04 is 5, all upon log 18 is 3 minus log 2. Okay, the first thing that we have to do here is to ensure that the term on the numerator is just a single term, and also the terms on the denominator will also be single term. But here we have two logarithmic terms. Yes, so we are going to reduce it to a single log term. And how do we do that? If we look at this, the bases are the same, and the operation between them is negative. The second law of logarithm, when we have log m base a minus log n base a, something as saying log m divided by n base a. So we are going to apply this law here to reduce this to a single log. Okay, let's do that quickly without taking much time. So we can still leave this man the way it is, log 0.04 in base 5, all upon log. Applying this, the bases are the same, base here 3, base here 3, then the sign between them is negative, so we have log base 3. So we now divide 18 by 2. Okay, and when we do that, we are going to have log 0.04 in base 5 divided by log 2 divided this is 9 in base 3. Okay, we have log 9 in base 3. Okay, we move further. Now, we can only divide two logarithms if they are of the same base, but now the base here and the base here are not the same, so we cannot possibly divide these logarithms, except we now use the rule of simplifying expressions that contain single log terms. So let's modify this. This is in decimal fraction. If we express it as a vulgar fraction, we're going to have that log 0.04 is actually 1 over 25 base 5, all upon log 9 base 3. Okay, now if we move further, somebody may be asking how did we arrive at this. Okay, 0.04 is something as 4 over 100. So 4 here, 4 here is 25. So that's how we arrived at 1 over 25. So we can now begin to express this in this form, because this can be simplified. Yes, looking at 9 and 3, we notice that 9 is a multiple of 3. So we can express 9 as powers of 3. Yes, as a power of 3. We can express this 9 as power of 3. So we can actually write this as log 5 over 1 over 5 raised to power 2, because 25 is 5 raised to power 2, divided by log 3 raised to power 2 base 3. Then we can move further again to have log 5 raised to power minus 2 in base 5, all upon log 3 raised to the power 2 in base 3. How did we arrive at this? You remember the law of indices, that a raised to the power minus 1 is 1 over a raised to the power m. So a raised to the power minus m is equal to a raised to the power 1 over a raised to the power m. That's what we have. So a raised to the power minus m is 1 over a raised to the power what? M. So if I have this, I can write it in this form. So if a raised to the power minus m is 1 over a raised to the power m, that means 1 over a raised to the power m is the same thing as a raised to the power minus m. So if 1 over 5 raised to the power 2 is equal to 5 raised to the power minus 2, that means 5 raised to the power minus 2 is still this. So if 5 raised to the power minus 2 can be written as 1 over 5 raised to the power 2, it means that 1 over 5 raised to the power 2 can also be written like this. So it can move in both directions. So that's how we arrive at this. Now you remember that the power of a number in logarithm is the same thing as the coefficient of the log. So if we use that law, remember the law that log m raised to the power p in base a is p log m in base a. So the power is also the coefficient of the log. So if we apply this law here, we will have, we're going to have minus 2 log 5 base 5 all upon 2 log 3 base 3. Okay? So log 5 in base 5 will give us what? 1. And log 3 in base 3 is 1. The logarithm of a number to its own base is 1. We know that. So this will give me minus 2 times 1 all upon 2 times 1. And that will give us minus 1 at the end of the day. So this should be our answer. All right. Thank you for following us. Remember that if it is under exam condition, you will not be spending all the time trying to solve one question. You have about 40 seconds for one question in your UTME, so you don't have time to waste. So you must be very fast. And that's why the only way to be fast in doing calculation is to make sure that you expose yourself to so many questions before the exam. So that if I'm the one solving this, by me looking at this already, I know it's 1 over 25, and I know I have minus 2 here. I know that 2 should divide this to give me 9, and I know that log 9 in base 3 is 2. So it becomes easy. So you need to expose yourself to different questions. After watching this video, pick your UTME past question. Solve as many questions as possible on logarithm. That's the only way you can be familiar with these numbers and also solve your problems with high speed and also with high accuracy. Thank you for watching us. And do well to subscribe to our YouTube channel and make sure that you follow us also on Facebook. Remember this.